My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 446. In this lecture, we will try to understand feature binning. The next feature engineering hack or technique is called feature binning. Feature binning is a logical extension of indicator variables which we discussed in our previous lecture, that is lecture number 445. Let's take an example so that you can understand better. Imagine I have height as a variable or feature. Initially, in the previous case, we said if height is greater than 150 centimeters, then return 1, otherwise 0. So here I will do it slightly different. We say if height less than 120 centimeters, return 1 or category 1. If height is less than 150 centimeters and greater than or equal to 120 centimeters, return 2. If height less than 180 centimeters and greater than or equal to 150 centimeters, return 3. If height is greater than 180 centimeters, return 4. Here what I am doing, here instead of having one threshold like in the previous lecture, I have multiple thresholds here. What are the thresholds here? 120 centimeters, 150, 180. Just let me keep all threshold values like this. If a person height lies here, let me assume if your person height, if it is here, let me say like this. If person height is here, then he belongs to class, that person belongs to class 1. If a person height in this region, then belongs to category 2. In similar manner, if height lies here, category 3, if height lies here, category 4. Here instead of binary indicator variable, you have multiple values into which you are bucketing or binning. This whole region is breaking into 4 bins. If you think about it logically, this bin 1, this is, what is this? This is bin 1, this is bin 2, this is bin 3, this is bin 4. That's why it is called feature binning. It is also called feature bucketing. Some people also call feature bucketing. Feature binning is much more easy idea. Given a real valued feature like height, we are going to break it up into multiple bins. Now, the big question here is, how did we get these right thresholds? Here we have 120 centimeters, 150 centimeters, 180 centimeters. How did you get these right thresholds? It's an important problem. As I told you earlier, getting to the right thresholds is very, very problem specific, very, very task specific. This is one of my favorite interview question. My favorite interview question is looks like this. It tells a lot about how good, how well people know feature engineering. Let's take a task here. Imagine my task is to predict gender. Imagine my task is to predict gender given features like height, weight, hair length, eye color. Given these 4 features, I have to predict. What are these 4 features? Height, weight, hair length, eye color. I have to predict the gender, isn't it? I have table here. But in table, height, weight, hair length, eye color, I have to predict gender. This is my data set. These four things, height, weight, hair length, hair color, constitute my xi, that is data point, which is my yi, which is gender. Gender is again binary. Let's assume yi is 1 for male, 0 for female. Let's assume this is given, my data set is capital D. Let's only focus on the height feature right now. Now you want to convert your height feature, you want to perform feature binning. Given the data, one way to do feature binning is to use domain knowledge. let's say, okay, to predict gender, of course, most men tend to be taller than 150 centimeters. But again, how do you do the big how do you do the big challenge, the big feature engineering challenge is how do you binning of height h feature using your whole training data, capital D, using whole training data set. How do you do very sensitive, very data, I can say it's very data driven. How do you perform very data driven binning or data motivated binning of your capital D, that is data set? This is one of my favorite entry question. Solution for this is looks like this. This is not necessarily the only solution or the best solution, but fairly good solution. So what I would say here, let's build a new table which is your height random variable or height feature and gender feature. See, what is the task? Let's not forget our task. Our task here is to predict the gender given these features. Which features? Height, weight, hair length, eye color, isn't it? So I will construct a table where I only have height as my feature and height as my feature and gender. What is the whole task of binning? Whole task of binning is to reframe or to design a new feature out of h height, which solves our task. Our task is to predict gender. Our task is to predict gender. So it always makes sense. It makes logical sense to use yi's and gender g is nothing but gender here. Gender is nothing but your yi's because you want to predict your yi's. So it makes sense. It makes sense to use the data which is in the yi's to perform binning on your height feature. So I construct a table like this. On this table, I will train decision tree, a sample decision tree, not a very deep decision tree, fairly balanced tree. Training a simple decision tree just using one feature. This is my xi. What is my xi? Height is xi, and this is my yi. Gender is yi. Remember, this feature h is real valued feature. I do not overfit a decision tree. I build simple decision tree, reasonable decision tree. Let's assume decision tree looks like this, isn't it? If h less than 130 centimeters, yi equal to 0. That's what it does. Decision tree comes up with these threshold 130 centimeters. Just recall how decision tree build using these thresholds. If we have only one feature, it will sort these features and keep finding right threshold. Decision tree is trying to find these thresholds 130, 180, 150 like this, isn't it? Thresholds using decision tree is trying to find these thresholds using information gain. If h less than or equal to 130, let's assume yi equal to 0. Let's just say, suppose this is the outcome I got. Let's assume this is the outcome I got. Now given this outcome, I have 4 leaf nodes, isn't it? What are the leaf nodes here? yi equal to 0, isn't it? I have 4 leaf nodes. These are the leaf nodes, isn't it? Just see. This is leaf node, this is leaf node, this is leaf node, isn't it? I have 130, 180, 150 as thresholds. Now I can write it as if else conditions. If h less than 130, return 1, because decision tree construction find these nice thresholds for you using information gain. These are very, very good thresholds if you had only height as a feature, because decision tree is fairly good model to start with. If you had only height as a feature, decision tree found these thresholds to be very useful. Let me see how to convert this into if else conditions. Now I will say if h less than 130, return 1, h greater than or equal to 130 and h less than or equal to 150, return 2. So this first condition if h less than 130 is corresponding to 1. Just see this first condition, this one corresponding to this one is corresponding to this one, this one is corresponding to this one, and this one is corresponding to this one, isn't it? So corresponding to every leaf node I have category. Just carefully observe how I created this. Corresponding to every leaf node I created a category, and this type of featureization, this type of binning we get here. What we have done here, we have binned a real valued feature like height, isn't it, using yi's and the feature itself. Using decision tree, this is very nice hack which I learned. It's a beautiful hack I learned. It is a beautiful hack that I learned while reading up published papers. Whenever you want to bin real valued feature, one of the very good featureization, very smart ways to bin it is to create dataset to create a dataset like this, isn't it? Building decision tree, use the threshold. Building decision tree, use the threshold that decision tree finds to construct your binning. It works like magic. I have seen this to do miracles. Actually, I have seen lots of Kaggle computations, Kaggle computations use decision tree based feature binning. What we do here, we are using a model like decision tree for feature engineering. Using decision tree to do feature engineering, feature binning, we will see again and again these concepts in our future lectures also. Time being, just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.